Okay, good afternoon students, am I audible?
Yes, sir.
Good afternoon, sir.
Okay.
Yes, sir.
Okay, my screen is visible?
Yes, sir.
Okay. So today we'll perform the third experiment, that is you have to polarize a transistor correctly so as to amplify an AC signal using multipin, and that experiment has another part, that is you have to determine the amplifier gain using body analyzer. Okay. So the experiment C has two parts, that is C and CB. Today we will have to do the CA part, and on Wednesday we will perform the CB. Okay. So basically, the first part is to perform the transistor as an amplifier circuit. Okay. So that means you will go for the small signal analysis of the transistor part. Okay, common emitter transistor. So as you know, this one is your voltage divider circuit of the common emitter configuration, and you have to use this circuit for the DC analysis, okay, and for the AC analysis, right? So for AC analysis, this can be done in two types. That one can be done by using the on bypass capacitor, okay. So this one is your using on bypass capacitor, and this one is your using the bypass capacitor, okay. So this one is your voltage divider circuit. This one is the C1 and C2 are the coupling capacitor, and the C3 is the bypass capacitor, right? So you have to perform these two circuits using the multisim, okay, and after that you have to find out all the parameters like VB, VC, VE, IB, IC, IE, and VC. Okay. So I will write down the parameters for VB, then VC, then EE, then IB, okay, then IC, then IE, then VCE. Okay, this much parameters you have to find out. That means you have to find out the parameters in theoretical, and then you will find out by doing the alteration circuit. That means the practical. Okay, then find out the percentage of error between them. Okay, so one thing who can say what will happen in case of DC signal? If I will perform the DC analysis of this circuit, then what will happen? What will happen to this capacitor part? Who can say? କଣ ହବ? DC current. That means the F value in the DC analysis, the frequency value is 0, right? So the reactance value, that is your XC, will be what? 1 by 0. That means it will infinite, right? So all the three capacitors will act as open circuit, right? Capacitors will open. I'm writing in short form, okay? Open circuit. So this is the case of DC analysis. But what will happen in AC analysis? You can say. in AC analysis the frequency cannot be zero. That means there must be some frequency, right? So F cannot be zero, right? So we have the XC formula is what? 1 by 2 pi I'm writing in symbol, okay? 2 into pi into F into C, right? So 1 by 2 pi FC, right? So as the C value is high, so the XC will happen, XC will be what? 1 by large value. That means it will nearly equal to 0. That means the reactance offered by the three capacitors is nearly equal to 0, right? So the circuit will, the capacitors part will short circuit, right? Right or not? So you have to find out the that means you will give the AC signal input here, right? And you will get the amplified output here, right? Similarly, you will get the input here and you will find out the output here, right? So design the circuit first, then you have to use the condition of bypass capacitor and without the bypass capacitor. Then find out all the theoretical values for the VB, VC, VE, IB, IC, IE, VC. Then connect the multimeter here in the circuit and find out the practical values for this parameter. And then you will find out the percentage of error between this. Okay. So how can you find the theoretical value? Who can say? This one is your voltage divider circuit and this one is your Thevenin equivalent of that voltage divider circuit. This part. Right? So the equation will be what? If you will apply the KVL in the input loop. କେତେ ହେବ? VTH କୁହ ଆରେ ଏଠି ମୁଁ ଏଠି KVL ପକେଇଲେ କେତେ ହେବ ଇନପୁଟ ଲୁପ ରେ ସପୋଜ ଏଠି ମୁଁ KVL ପକେଇଲି ତାହେଲେ କଣ ହେବ? Am I audible or not? IB into RTH. Okay, then after that कौन सा वो minus VBE minus IE into RB. RE हाँ होला equals to कितने 0. Then you will find the IB value from here. Right? IB value find out कले कौन पाइबो तुमे? IE value find out कर परिबो. IE value केते होबो? Beta plus 1 IB right? Again IC equals to केते? Beta IB right? तो एमती करिकी तुमको सबुर theoretical value find out करार अछि जोटा कि एठी मु लिखि छि जो parameter हला. Then again you have to measure the practical values from the multi-sim circuit. Okay, then you will find out the percentage of error between them. हला तो table बनेबो, table रे होछि एसो parameter रखिबो, then practical value and theoretical value and percentage of error. right? ଆଉ ତାପରେ ତାର output waveform. That means ତମେ ଯଦି input signal ଟା ତମେ ପାଉଛ, that the output signal must be in the amplified form, right? ଏ ତିନି ଜିନିଷ ମୁଁ ଦେଖିବାର ଅଛି in the part A, and part B will perform on the Wednesday. Okay, so now try in multi-sim circuit. One more thing, there will be one phase difference of 180 degree between the input voltage and output voltage, okay, in the common emitter configuration. Okay, so you will get the 180 degree phase shift in the output waveform, right? So now check. One more thing, you will find out the gain also. Okay, so the gain is what? Output divided by input. So you will find out the gain for unbypassed capacitor and which is a bypass capacitor, and you will find out the which one will be better. Okay, which will provide the better gain. You have to find that. Okay, between these two circuits. Acha, one more thing. In the experiment 1, that is your diode experiment, right? VI characteristics of the diode. So in that experiment, the experiment was to determine the behavior of the diode using voltage current voltage current curve and understand their operation and application, right? So in that application part, you will perform any one of the circuit like flipper or clamper or rectifier circuit. Okay. Again, the rectifier circuit can be of full wave, half wave. Okay. According to your choice. So write down any one of the application in that experiment. Okay.
सर्किट कर सारिलुनी हेले करिवार कोन अछि मैं
Are first what you have to check? You have to check the output which is through the capacitor C2. Okay. Compare it with the input. And your output should be amplified one with 180 degree phase shift. Okay. You have to first check this. Then you have to find
in CRO.
Yes, in oscilloscope. And you have to first of all find out the theoretical values of these parameters, that is VB, VC, VE, according to the circuit you have designed. You know all the values of your resistor and your supply voltage. Yes or no?
Yes.
So according to the DC supply, what is the value of these? And you have to check the values of these parameters through the multimeter, okay? And then you have to find out the error. If anyone has completed your circuit? Yes, anyone?
And circuit is completed, but output is not as per the desired one.
Share your screen.
Yes, ma'am.
आउटपुट नेगेटिव पार्ट टा कट हे आसी
देखो वेट करो
This one is for the bypassed capacitor.
What is the value of beta you have taken?
Beta value I need to change here, ma'am. I don't know.
Yes. You know how to change it?
No, ma'am.
Double click on that transistor.
Yes.
Go to edit model. Edit model. It is below. You can see, yes, edit model. No. Close this. Do once again. Edit model. Edit model.
Yes, ma'am. Yes, ma'am.
There is written ideal maximum forward beta. Yes.
Yes,
Click
ma'am.
on that.
Yes.
Click. Once again, click on that. Yeah. Change the value. Make it 300. 300.
Yes, ma'am. Yes, ma'am.
Okay.
Then I'll close it.
Yes. Close this. Okay. Now run it.
Like this, it is coming.
Okay. Okay. What you have to do? You have to make it auto. Make it auto.
Yes, ma'am.
Why this is coming like this? Close this once again.
Yes, ma'am.
No need of no need of connecting this common with the negative one. Either you connect the negative or with consider the common only. Okay, delete that part.
In the input section.
Stop the simulation.
Yes, ma'am.
Yes, input section function generator. Delete the negative connection, negative terminal connection. Yeah, delete it. So what you have, that's it. No need of connecting anymore. Okay,
Okay,
what
ma'am.
you have
Yes,
done,
ma'am.
10 microfarad. All the capacitors are of same value.
Yes, ma'am. I've taken all of 10 microfarad.
No, bypass the capacitor is having much more
Hun-
higher value. Yes, make it 100.
100. Okay, ma'am.
Okay, now check the output. Okay, you are getting this. Delete this oscilloscope and connect another oscilloscope. Okay.
Okay, ma'am.
Change this volts per division and times per division, then check it.
Okay, ma'am. I'll do this and again I'll
Okay,
share, ma'am.
do it and then share. Yes,
Yes, ma'am.
someone else is saying something. Sujit,
Ma'am,
yes, Subham,
can I show?
yes. Are you getting the output?
ସେଇଟା ଜାଣି ମୋର ଏମିତି
Good.
ଆସୁଛି ଶୋ କରୁଛି ଗୋଟେ ମିନିଟ୍ ମୋର ଏମିତି ଆସୁଛି ଗ୍ରାଫଟା ମାନେ
180 degree phase shift.
ରନ୍ କଲେ ବି ସେୟା ହିଁ ରହୁଛି ଏଇଟା ଠିକ ଅଛି
अच्छा एटाको 47 को
मैम
करो R1 को R2 को 10 करो same thing.
Yes, ma'am.
Go on for calculation of your theoretical value and check the value of your voltage and current here.
Okay, ma'am. Ma'am, unbypass टा देखेबी?
Stator is same.
Okay.
देखो. Done करो.
एहिठारे टिके एमिति आसुची.
Clip take. Okay, 1 microfarad change करले कौन आसुची?
मैं 10 टाको 1 माइक्रोफैराड कर दूं. सेम रोजी
मैम 0.1 माइक्रोफैराड कर ले इसको
क्लिप થઈ જાવ છે રાઈટ
यस मैम
કરો કમ નહીં દિયો કેપેસિટર વાળી
0.1
But still you are not getting the negative one, it is flipped.
Yes, ma'am. ଏମିତି ରହୁଛି.
Increase the voltage.
Hmm.
Not that voltage. Volts per dozen.
ମୁଁ କେତେ କରିବି?
अरे volts per division.
ଏ ଚ୍ୟାନେଲ B ର ଏଇଟା.
अरे decrease करो. तुमको देखा जाଉଛି signal ଏବେ.
ଏମିତି ହେଇଯାଉଛି.
आउरे decrease करो. But still you are not getting the amplified one. You have changed the beta value.
Yes, ma'am. 300 कर दीजिए. 300.
Then why you are not getting? Okay. Fine. Calculate the value of voltage.
Okay. Should I stop sharing?
Yes, you have calculated the theoretical value.
No, ma'am.
Do it.
Yes, ma'am. Gotcha.
Excuse me, ma'am.
Yes.
Ma'am, I think I'm getting the correct output.
Okay. I am also getting the correct one, but I don't know what is the problem with the connection with you guys. Yes, it is correct.
Yes, sir. And for bypass, I'm getting.
Yes. You have taken the same transistor.
Yes, ma'am.
Show me the unbypassed one. 10 microfarad, 10 microfarad, 1K, 10K, 4.7 is the same connection I have given to this Priyaranjan. Priyadeep. Open the function generator. What is the value you have taken? Yes, by this only. Why? I don't know. I'm not understanding why is not getting the output. Priyadeep.
Yes, ma'am.
This was the same connection I have told you.
Ma'am, in fact, I had also made the same connection, but I don't know why I am not getting that.
That is what I am not understanding. Okay, yes, Surya, you go for calculating the value of your current and voltage, okay?
Yes, ma'am.
Check you have sorted to register and then you have connected to base. Priyadeep.
No, ma'am, I have not done that.
You are doing voltage divider, right? R1, R2, you must be sorting both of them. Then you have connected to base.
Wait a minute. Yes, ma'am, yes, ma'am.
Then you have given the capacitor or you have directly connected the capacitor with the base.
No, ma'am, I had connected, yes, I think I had connected directly.
And then?
Sorry. Okay, ma'am, let me check and ma'am, I will tell you.
Yes. Do it. What about others? Okay, by today evening, at least what you have to do, by today evening or by tomorrow evening, okay, before Wednesday, all of you will give the PDF of your layout of unbypass and bypass, output of both, okay, with the phase shift of 180 degree and the amplified signal. And also you will write down the tabulation for theoretical and practical values of those parameters that Siddharth sir has told you, okay? All of you know which parameter you have to find out?
Yes, ma'am.
So make the tabulation, take the photo of that, and send it to me. And also, I have created a link for the submission of your lab record for experiment number 1 and 2. Okay. For now, we have left one part in experiment number 1, that is the operation of your diode. So for that, what you have to do, you have to make a connection for either clipper, clamper, or your rectifier circuit. Okay, no need of doing, all of you are going to do the same circuit, it is not required. Okay, you can choose one of the circuit as an application. What are those? Clipper, clamper, or rectifier circuit. Okay, for the application of diode, you have to design it, and also you have to show the output to it. Okay. After doing that, you will do the submission. Understood?
Okay, ma'am.
Yes, ma'am.
All of you are getting it? All of you make different circuit, okay? Okay, no need of submit. नहीं चेष्टा कौन सेटा कौन सेथिरे गोटे रजिस्टर डायोड लगे तुम सर्किट बने परिबनी चेष्टा कौन सब हबो तुम करिवो तापाई I can't give you one more extra class for that. All of you know the concept of those circuit. Only what you have to do, you have to design and check the output. That's it. Tell me whether you can do it or not. Yes.
ना कहले भी तो आपण कहिबे करिया तो माने करियार तो अछि करि दबु
करिबो कोन हबो ना हबनी मते सेटा को
मैम हे जीवो मैम
हां तो मैं ट्राई करो. If you won't be able to do it, then let me know. Okay.
Sure.
हबो सेटा को. So what you have to do, all of you have to submit the PDF to me, okay, by tomorrow evening for this experiment. Okay.
Yes, ma'am.
What? Okay. Okay. Attendance, and thank you for the class.